Okay, everybody, so we are about to learn a new technique for solving indefinite intervals. And an indefinite interval is something like this. You could also call an indefinite integral an antiderivative. And when I say that, of course, all I'm saying is that if this here is the answer to that, then if I take the derivative of this, then I should get back with what I started over here, okay? All right, that's why we call it an antiderivative. Now, so we're about to learn a new technique for doing those that applies to a certain kind of problem. But before we do that, I think it'd be good if I could get you to notice something, all right? So look at this problem, and I'm not going to work this problem. Here, it's already done. Everything I want to show you is already on paper. But like I say, I want you to notice something about it, okay? So here's the question. It says, what's the antiderivative of 4x to the third power times x to the fourth plus 1 to the ninth power? And then I give you this answer. And even if you don't know how to do this problem, I can convince you that this is the right answer. Because if I take the derivative of that with a rule that we should be familiar with, we've already learned the rule, then I can get what I have over here, okay? Now, here's what I want you to notice. You see how this is x to the fourth plus 1, and there's an x to the fourth plus 1. And that was a 9, and in the answer, it's a 10 and a 10, okay? So it's kind of like how we would say, like, what's the antiderivative of x to the ninth power dx? Well, that's x to the, what's 9 plus 1? 10. Okay, x to the 10th power over 10 plus c. It's kind of like that. It's like I took this, and I added a 1, and I got 10, and I divided by 10, and I put plus c. All right, so you might notice that about this. Okay, so I want you to notice something. So I want you to notice that about this. But why isn't this part here involved in the answer? How come there isn't a 4x to the third power? Or how come there isn't anything like this over in the answer? All right, so take a minute or take 10 minutes to think about that if you need to. But I want you to think about that, and I want you to notice it. Now, the answer to why this is in the question, but it's not in the answer, is because notice when I check the answer, that 4x to the third, that's a byproduct of using the chain rule, right? So when you take the derivative of x to the fourth plus 1 to the 10th power, you bring the 10 down to the front, you take 1 away, you get 9, and then you take the derivative of that inside part, all right? So that's why it was in the question, but it wasn't in the answer. Okay, so just let that sit, let that be something that you think about, let that be something that you have in mind when you look through my next videos, maybe 2 or 3 more videos that come after this, and you're learning the technique, all right? I think the technique will make a little bit more sense if you can at least have thought about this a little bit, all right? Okay, so that's right there in the red bubble. That's what I wanted you to think about a little bit as you saw this question. I'll show you one more example like this, okay? So look at this. This question says, what's the antiderivative of sine squared x times cosine x dx, okay? And the answer to that is sine to the third power x over 3 plus c. And I'm not concerned about how you get that answer at this moment. I just want you again to notice something. How does it look like you get that answer? Over here, I said, well, it kind of looks like you take that and you add 1, and then you divide by that same number, and you put plus c. And I said, why we left that out? Why isn't that in the answer? Why is it here, but it's not in the answer? Oh, the chain rule, checking it, all right? It shows up when you check it. That's why, all right? So here, why? So sine squared, the answer, so sine third power over 3. So it looks like you take that 2 and you add a 1 to it, you get 3, and you divide by 3 and you put plus c, okay? Why isn't the cosine in the answer anywhere? Or why isn't this part, why doesn't it seem to be involved in the answer? Okay, so think about that. Well, let's check it and see. What makes this answer correct? If you were to take the derivative of this, you should get that. So let's do that. What's the derivative with respect to x of sine third power x over 3. Well, first of all, when we put our exponent like that, we mean the order of operations to be like this, that it's sine of the angle x first, and then take that number and raise it to the third power. So I deliberately wrote it that way, just because that's something that people overlook every now and then. So, okay, so yes, that's what it means. So the derivative of sine to the third power x over 3 plus c, well, that 3 that's a 1/3 right there. It's a constant, all right? For the sine third power x, we'll bring the 3, the power to the front, and we'll take away 1. And then we got to multiply that by the power of the inside, or by the derivative of the inside. Derivative of sine's cosine. Okay, so what's this then? The 3's cancel. We get sine squared x cosine x. Okay, and that's what we started with. That's why this is not involved in constructing the answer. That's why that cosine appears in the question, but it doesn't appear in the answer. The sine appears in the question and the answer. The cosine does not. The reason it doesn't is just because it shows up when you check the answer. So there's the rule you use, right? The derivative of u to the n power, n times u to the power n minus 1, times the derivative of the u with respect to x. So yes, that's what I do. When you do that, when you check this, that cosine shows up. That's why it's there. Okay? Now that might seem like a weird way of thinking about the way something works, how something is in the question because it's a byproduct of the way the answer works, but that's the truth about it. And we're going to have to learn to look at things that way. Okay? So, all right, this is there because it shows up when we check the answer. All right? This is there for the same reason it shows up when we check the answer. This is not in the answer, but it's in the question for that reason. This is not in the answer, but it's in the question for that reason. So think about that a little bit. Let it sink in if you need to. Give it some time. And just let it be there as we go to the next videos and we see an actual technique. The technique will make a little more sense, and I think it'll be easier to learn and understand if you've had this exposure.